Friends, in last video we have seen types of the brakes, and we have came across to this band brakes, and we have seen how that band brakes are, and how that band brakes are considered, that is band is used. Now there are two types of band brakes. One is called as simple band brake, and second one is called as differential band brake. And we'll see how that band brakes are having construction as well as how they work. First of all, we'll see the simple band brake. In case of simple band brake, what actually is considered, that simply one lever is used. At the one end of that lever, one end of that rope or band is connected, and the second end is connected to that lever. Second end of that band is connected to that lever, and against that fulcrum is used. Here you can see the diagram. In case of this diagram, fulcrum is at point O, so external force is applied on that lever, and it is applied in upward direction, so that the pressure which is applied by means of band on that drum will get increased, and that increased pressure will create the force, that is normal force, and it will create normal reaction, and this normal reaction is used in case of that frictional force. So frictional force will get increased if the normal reaction get increased. And as you are going to see in this diagram, one end is connected to the that fulcrum, and second end is connected to the lever. So always in case of simple band brake, one end is connected to the fulcrum, and according to the application or size of that drum, other end is connected to that lever. And as where we need the multiplication of applied force, the length of that lever is calculated by means of that. Here also this distance is important, that is L, that is distance of fulcrum from the applied force, whereas distance B is also important, where we are going to use that B, that is the distance of other end of that band is connected to the lever to the fulcrum. These distances are important while we are going to calculate the force on that braking system or this type of brakes, while we are doing the analysis of forces. Now next type is the differential band brake. Now what is difference between that simple band brake and differential band brake is that the band is connected always to the fulcrum in case of simple band brake, whereas in case of differential band brake, that two ends of that band or rope or belt which is used as a band is not connected to the fulcrum. It is connected at the extended part of that lever. So this extension can be done in straight direction, that is in line with that lever, or it may have given some angle, so that we can multiply that force, and that is applied force, and we can get the more or better results. In this case, this angle of wrap is also important. When we are going to calculate that angle of wrap, it will give us the method by means of which we can calculate the frictional force. Now the distances which are important are the length of that lever from the fulcrum, where we are going to apply the force, external force, then the end where the one end of that band is connected and second end of that band is connected. These 2 points are important, and their distances from the fulcrum is also important while we are doing the force analysis. Now this is how the differential band brake is. Now how it acts, that is when we are applying force, external force, then because of the application of that external force, the pressure will generated because of that band, and this pressure ultimately will converted into normal force, and we get the normal reaction, and hence the frictional force, that is F we suffix normally called it as, will get increased by means of the formula that frictional force is equal to normal reaction multiplied by the coefficient of friction, that is Rn multiplied by mu. Mu may be constant because it is a material property, and for the given material, that mu, that is coefficient of friction, is constant. Approximately it is considered as a constant. It is also depend upon the surface roughness also. So if the surfaces are rough, coefficient of friction is higher. If the surface roughness is that is surface is smooth, then coefficient of friction will get decreased, but it has a little value, that little change. Most of the case, in case of frictional force, Rn, that is normal reaction, is playing very vital role. The next type we are going to see, that is band and block brake. In this case, you can see in the diagram that small blocks are connected with the band, and these blocks are mounted in such a way that when that band is wounded on the drum, these blocks are also get wounded on the drum. Now, a band and block brake consist of number of wooden blocks fixed inside a flexible steel band. Normally, steel band with very thin uh, band is used, or leather band is also used. When the brake is applied, the blocks are pressed against the drum. The friction between block and drum pivoted, that creates the braking action. Now the advantage of this pivoting wooden blocks is that it provides a higher coefficient of friction, and they can easily replaced after the wearing. That is, when that block get wear out, they can easily replaced. It is quite difficult when we are going to replace the band. Frequently it is not necessary to replace that band. That wooden blocks can be replaced, and it will be effective braking also. Or braking, what are the braking requirements? That is, in minimum time that drum should get stopped, or its motion should get reduced, and easily that, after all, when we are going to create the frictional, that kinetic energy of rotation is converted into heat energy. So this conversion of energy, that is kinetic energy into heat energy, that should done fast. And while doing this braking system should not get heated. It should dissipate that heat to the atmosphere easily, and with fast rate. So that action take place easily in case of this band and block brake. Now this is the last type of brakes, which we are going to consider as a internal expanding brake, and these brakes are more popular in case of two-wheeler and four-wheelers, that is in automobiles. So what actually the construction is? Here you can see a complicated diagram, quite complicated, but it will become complicated while we are drawing. In that case, one cylinder is placed between two shoes. Now we can consider as a left shoe and right shoe. When drum is going to rotate, in the direction of rotation, one is called as leading shoe, another is called as following shoe. So in the direction of rotation, if we go in clockwise direction, then the first shoe which is coming, that is called as leading, and the latter shoe is called as that is, it is, as it is going to follow, it is called as following shoe. And these two shoes are important, or this terminology is important while we are doing force analysis. Now these two shoes are aligned with the friction lining. That is, normally asbestos is used as a material to create the friction line, for which the coefficient of friction is higher. So this asbestos is used. You might have seen in case of two-wheeler, the brakes or shoes, frequently we used to replace it after certain period of time. So you might have seen that shoes and are lined with the frictional material, and if that frictional material get wear out, then we are going to replace that shoes. Now when we are going to consider that shoes, they are bring together by means of spring force, and always they are in off condition, that is, they are coming together. But as we want to apply the brake, at that time the cylinder which has placed in between the two shoes creates the pressure, and it is called as wheel cylinder, in which two pistons are there, that is at every end or each end of that cylinder, and in between fluid is or pressurized fluid is supplied. When the pressurized fluid is supplied, it creates the pressure on that two piston, and they will move outside. As they move in outside direction, against that spring force, the force is applied, so that shoes will get pressed against the drum. And as the drum is rotating and shoes are stationary, that is again relative motion, so because of that relativity, that shoes get pressed against that rotating drum, and as we are increasing the pressure, increasing the force, they will create the more force on that rotating drum, and normal reaction will get increase. And as the normal reaction get increase, frictional force will get increase, and this frictional force is reducing the motion of that rotating drum, or it will bring that rotating drum to the stationary condition, it will stop. In this case, important part is that cylinder, it is called as wheel cylinder, then the spring, that is spring which is used, normal two springs are used, one at the upper end and second at the lower end. Now these two shoes are made, or fulcrum is used at the end, and they are pivoted at the end, that is at the lower side. Now as we are going to see this diagram, we can say upper side is the cylinder and lower side as a fulcrum, and with the stationary fulcrum, that shoes will get expand or they will get contract. And when we are going to release the force in that wheel cylinder, when we are releasing that pressure on that fluid which is in the wheel cylinder, then because of the spring force, that shoe will again come to the original position, and clearance is provided between that shoe and that drum, hence that drum can rotate freely. And at the time of application of brake, we are going to again provide the pressurized fluid inside that wheel cylinder, and the rest of the action take place, and braking is done as per the requirement. So this is about the types of that brakes. Next lecture will be there for analysis of the forces in various types of braking system, as well as in the various types of brakes. So thank you.